Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. Okay, today we are going to step in the fourth chapter, the first part of the first chapter. So this is the outline of chapter 4. So the first one we are going to discuss on some brief introduction into Laplace transform, some definition and the first principle of Laplace transform. And then we are going to look at the Laplace transform itself and the inverse Laplace transform, followed by properties of Laplace transform and application of Laplace transform, specifically in circuit analysis. Okay, the concept of Laplace transform. So basically, when we have a signal in time domain, so we used to use classical solution, for example, differentiation, integration, to solve the time domain function in order to get the final output. However, you can solve the time domain problems by converting the time domain equation into S domain, and then there's initial rules to be considered, and some modification or manipulation need to be done into the equation. Then you can solve the S domain function. Finally, you need to convert the S domain function into time domain function again to get the final answer. Okay, this slide summarizes the process involved in Laplace transform. So the first one, you have the signal in time domain. So you need to convert the signal in time domain into S domain. Next, you solve the problems now in S domain function. Next, you need to convert the S domain function back into T domain by using inverse Laplace transform. Finally, you get the final output. Okay, Laplace transform is useful to solve complex differential equations, such in electrical circuit and control system. On the other hand, the Laplace transform also is useful to develop a transfer function in which the transfer function basically shows the relation between the input and output of the system. Okay, as you may have get used to time domain function or time domain equation, in which it basically shows the relation between the input and output of the system. And also in differential equation in time domain function, you have seen the differentiation equation in which that yields the output of either 0 or any function. Okay, if the output equal to something, for example RT or 3T, this equation is called inhomogeneous equation. But if the RT equal to 0, meaning that if you have an equation that equivalent to 0, so the equation is called homogeneous equation. Okay, this is the first principle of Laplace transform. First, you have the signal in time domain. So to convert the signal into S domain, so you need to perform Laplace transform. So this L is called a Laplace operator, meaning that you will perform Laplace transform of the input signal in time domain. So this can be done by integrating the input signal Vt multiplied by e minus st dt. So the limit is from 0 to infinity. Then you get the equation in S domain. It's capital B and S. So to convert, once you have solved the problems by using S domain, then you need to reconvert the S domain into T domain again by using inverse Laplace transform. So in this L, the L to the power of -1 is the inverse of Laplace transform. You transform the S domain back into T domain by again perform another integration of the signal in S domain multiplied by E S T ds multiplied by 1 over 2 pi j. So this is the first principle of Laplace transform, meaning that you have to perform the integration both in the first place to convert the T domain into S domain, and finally when you want to reconvert it, the S domain back into T domain. Okay, so definitions of Laplace transform. When you have a signal ft, a function in time domain, so the S domain function of the ft is fs, meaning that when you have a signal ft, so the signal will be fs in S domain by performing the Laplace transform of the signal ft. So L, again, as mentioned earlier, it is the Laplace operator. So you need to perform the integration by using first principle by the limit of 0 to infinity, the input signal in time domain multiplied by e minus st dt. Okay, let's look at the first example. Given a signal ft equal to 1, so where t is larger and equal to 0, find the function of ft in S domain, meaning that you need to perform Laplace transform of ft. So L ft, so you will get the fs. So what is your fs? So in order to do that, you need to use the first principle, meaning that you need to integrate the given signal ft, in this case ft equal to 1, multiplied by e minus st dt, and the limit is from 0 to infinity. So perform the integration so that you get the fs equal to 1 over s. So in this case ft equal to 1, so when you do the Laplace transform, so you get fs equal to 1 over s. Okay, let's look at another example. So given ft equal to 3e7t, so find the Laplace transform of ft. So you have your ft, so you need to find fs. So you need to perform Laplace transform by using first principle. So this is the equation of first principle, so in which ft is given by 3e7t multiplied by e minus st dt. So perform the integration, so finally your fs equal to 3 divided by s minus 7. Okay, this is the Laplace transform function table. As you can see in chapter 3, Fourier transform, you can ease solving a function in frequency domain by referring to Fourier transform pairs or Fourier transform table. Same goes to Laplace transform. You can simplify the mathematical operation by referring to Laplace transform function table. So please refer to the complete Laplace transform table given in the e-learning. So the one that shows in this slide is just part of it. Okay, let's look at example solving time domain function by using Laplace transform, and you can refer to the Laplace transform table. So please take note that when you have an equation, for example ft equal to t, so when you plot a graph, you know that t will be something like this, okay, from negative value to positive value, so positive 2 to negative t. Okay, so in this course we are going to consider only the right hand side. Okay, so we only consider the right hand side, so we don't consider the negative side. Therefore we can assume that all equations, when you have this kind of equation, you can assume it is equal to t ut. This is called unilateral function, in which only one side or positive side will be considered in your calculation. Okay, so in this case ft equal to t, so we can assume it is ft equal to tut. So in this case t multiplied with ut, so we know that ut is this one, so only positive side will be considered. So ftut equal to this is t, ut. Okay, so by referring to Laplace transform table, so this is the closest shape to the given equation. So you have t to the power of 1 ut. So your n equal to 1 in this case. So it is equal to n factorial 1 factorial divided by s. Your n is 1 plus 1. So it is equal to 1 divided by s squared. So let's look at next function. So ft is given by EAT. So again, consider only the positive side. So we can assume this one equal to EAT ut. Okay, so refer to the table to the closest shape to your equation. So then compare the given equation with the one in the table. So this is from the table. So compared to yours, EAT, UT. So your E in this case equal to negative A. Okay, this is equal to negative A. Okay, so your E is negative A. So from the table, E minus ATUT will be given by 1 divided by S plus A. So your A in this case is negative A. So that's why the Fs equal to 1 divided by S minus A. Okay, this slide shows a comparison solving the time domain function by using S domain, by using either the first principle or by referring to the table. Okay, so by using the first principle, when you have a function of ut, so you perform the integration of ut multiplied by e minus st, so you'll get 1 over s. So when you refer to the Fourier transform table, the Laplace transform table, so ut is given by 1 over s. So it produces the same answer. Therefore, you can solve the time domain function in S domain either by using the first principle or simply by referring to the table. Okay, same goes to the next equation. You have a function of tut. So by using first principle, you perform the integration and you get 1 over s squared. If you refer to the table, so when you have t to the power of n ut, so it is in S domain, it is equal to n factorial divided by Sn plus 1. So in this case, your equation is t ut. So your power n is 1. So n equal to 1 factorial divided by S1 plus 1. So it is the same answer. So the third function, e minus atut. So again, using first principle, so you get this equation. So now compare with the table. If you have e minus atut, so you get 1 divided by s plus a straight away. So another example, when you have an impulse function, so by using first principle, you integrate them, so you get Fs equal to 1. When you refer to the Laplace transform table, so when you have Ft equal to del t, so your Fs equal to 1. So it is the same as the answer by using the first principle. Okay, more example by using for Laplace transform table. So you have multiplication of t with e60. So refer to the closest shape in Laplace transform table. So it is equal to te6t. So in this case, your t to the power of 1, e power of 6 t ut. So you need to be careful with the notation. So this is minus a. So you need to determine what is your a. So comparing the equation from the table with the one you have. So n equal to 1. So your A, it is negative. So A, to get positive 6, okay, this is positive 6. So to get positive 6, it is negative. This is from the equation, so negative. So to get positive 6, so your A will be negative 6. So then you can replace all parameters inside the equation. So your fs in this case equal to n factorial. So this is n factorial and 1 factorial divided by s plus a. So a is negative 6 to the power of n1 plus 1. So this is your answer. Okay, let's look at another example. So when you have ft equal to e minus t sine 2t, so again refer to Laplace transform table. So this is the shape you have in the table. So you can compare the given equation with the one in the table. So you have e minus t sine 2t. So in this case, you know that your a is equal to positive 1 and your omega equal to 2. So you can simply replace all parameters by the values you have. So now you have the fs equal to this. Okay, let's look at the third example. So this is combinations of more than multiple components inside an equation. So to solve this kind of equation, you need to perform some modification into the equation so that you can solve the equation easily using the Laplace transform table. Okay, sometimes you may find different combinations in the table, but then you can choose which one is simpler and can ease your calculation. Okay, so for this kind of function, from the table you may find a combination of this equation e minus atft. So in this case, if you compare to the given equation, it is equal to e to t. So your ft equal to t sine 3t. So meaning that your ft is this and this is your eat. So in S domain, it will be fs plus a. But from the table also, you may find this function. You have ft sine omega naught t, in which if you compare to the given equation, it is equal to, this is the sine 3t. So your ft is basically te to t. So this is your ft. And in S domain, the equation will be something like this. And you may find another function. You have t to the power of n ft. So if you compare to the given equation, is t to the power of 1. So your ft equal to e to t sine 3t. This is your ft. Okay, and this is the S domain function for if you are using this method. So you have 3 methods basically. Okay, so now you need to choose which one you want to use in order to solve this function. Okay, so look at the S domain equation. So which one is simpler? So this one looks quite straightforward because in the bracket all S will be added by A. But in this one, it looks a bit more complicated because it involves the j function. And the third one, in the third method, you need to differentiate the S domain function. Therefore, number 1 is a bit more simpler if compared to method 2 and method 3. So in this case, I'll choose method 1. So now, this is the given function. So you can rewrite the equation, the given equation, to suit the function you have from the table. So from the table you have this function e minus at f In this case, I name it as f1t because the general equation is given by ft. So it is equal to, in S domain, it is f1s plus a. Okay, so now compare the given equation with the value you have. So this is from the table. So this is from the equation you have. So e to the power of positive 2t. So now from here you know your a equal to negative 2. Okay, so your equation here will be f1s plus a. So your a is negative 2. That's why you get this one. Okay, so what is your f1s? So f1s must be from f1t. So what is your f1t in this case? So f1t is equal to this. Okay, so now find the Laplace transform of your f1t. Okay, so f1t will be producing f1s. So refer to the table. So t sine omega t will be equal to this in S domain. So compare to your equation t sine 3t. So you know your omega equal to 3. So replace the omega by 3 and then you have your f1s. Okay, so go back to the basic equation, e minus at, this one, equal to f1s plus a. Okay, and this one, this is when you have entered the value. So f1s minus 2, meaning that all s must be deducted by 2. Okay, so f1s minus a equal to 2 times 3 is 6. So your s now become s minus a. So your s becomes s minus a. So your fs equal to this function. Okay, so you need to be able to modify the equation to suit the function you have and to suit the function you found from the table. Okay, next, once you have solved the function in S domain, so you need to reconvert it back to T domain as the final answer. So either you need to use the first principle if the Laplace transform table is not provided, or you can simply refer to Laplace transform table if it is available. So again, you need to perform some modification to the equation you have so that it can fit or it can suit to the basic equation in the Laplace transform table. Okay, so for example, you have fs equal to 10 divided by s squared. So what is your ft? So to get ft, you need to perform the inverse Laplace transform of fs. Okay, then you get the ft. So now refer to the Laplace transform table. So if you have this function, so the closest one will be this equation in the table. So now you need to convert this equation, to modify this equation a bit, so it becomes 1 over s to the power of 2. So 2 equal to 1 plus 1. So from here you know that your n equal to 1. So here is 1 factorial. Okay, so now you know your n equal to 1. So it is equal to t to the power of 1 ut. Okay, and don't forget you have 10 here. So it is multiply with 10. So it is 10 TUT. Look at the second example. So you have fs is given by 10s. So you can modify this a bit. It's equal to 1 over s. If you refer to the table, you have this shape. So 1 over s equal to ut in time domain. So now multiply by 10. So your ft equal to 10 ut. So next example, fs equal to 10. So refer to the table. When you have del t, the s domain is 1. So in this case, you have 10. So this is equal to 10 times 1. So this is equal to del t in t domain, multiply with 10. So the final answer is 10 del t. Okay, let's look at another equation in inverse Laplace transform. So given is fs equal to this equation. So fs equal to 3 divided by s squared. So what is your ft? So ft equal to the inverse Laplace transform of fs. So by referring to the table, so this equation, your fs is equal to 3 1 over s squared. Okay, so refer to the table. So the closest function is this in this shape. So again, you know s to the power of 2, s to the power of 2. So you know it is 1 plus 1. So here your n equal to 1. So you know the power of your n equal to 1. Okay, so in this case, you have 3 1 over s1 plus 1. So this is equal to 3t to the power of 1 ut. Okay, so you have 3t ut. So same goes to the next example. So you can try this out. Okay, let's look at another two example in inverse Laplace transform. So again, you need to modify the equation a bit to suit the equation you have from the table. So from the table, when you look at the denominator, so you know s squared plus omega squared. So in this case, omega squared equal to 25. So you know your omega equal to 5. Okay, so to get sin function, the equation must be having omega on top, but your equation having 1 on top, meaning that you need to multiply the equation by 5 by omega. So in this case, you need to have 5 1 divided by s squared plus omega of 5 squared. Okay, but the original equation only have 1, so you need to introduce another function 1 divided by 5. So when you cancel this out, this is again equal to the given equation. So in this case, it is equal to 1 over 5. So this is already in this shape. Okay, already in this shape, so you know it is a sin function. Omega equal to 5 t u t. Okay, same goes to the next example. So given is 2s. So from the equation, you may see that you have s on top, so it belongs to the cost function from the table. So you can modify this equation a bit. So it is equal to 2s divided by s squared plus, if you refer to the equation, is omega squared. So your omega squared equal to 10. So your omega equal to 10. Okay. So it is 10 squared. Right? So this is already in cosine shape. So it is equal to 2 cos, your omega is 10 t ut. So this is your ft. So with that, I end the first part of Laplace transform.